Okay, so for these, remember to find the implied range, the first step is to find the degree of precision. So for this first one here, 2.175 inches, what's the degree of precision? Yeah, thousandth of an inch, 0.001 inches. It is the place value of that last digit. Step 2 is then to find the possible error or the implied error. Well, the possible error is always 1/2 times the degree of precision, right? We'll just do times 0.5, which would be plus or minus 0.0005 inches is the implied error, the possible error. So then the implied range goes from that measurement minus that possible error, that'd be 2.1745 inches, to that measurement plus that possible error. So 2.1755 inches. Does that look familiar? So over here, what's our degree of precision? 0.01 centimeter. So my error would be plus or minus 0.005 centimeters. So my range, 4.83 minus 0.005 is 4.825 centimeters to 4.83 plus 0.005, 4.835 centimeters. Any questions on those? Okay. Well, then today we're going to shift gears a little bit and look at the measuring device, one of our precision measuring devices, a caliper. In fact, I want to take a quick look here. So this here is just kind of an overview. That is a picture of a dial caliper, one form of a dial caliper. It's the jaws. You have the main scale, which is this part right here, the bar of the caliper, which is kind of like a ruler. It has measurements listed out on it, and we'll look at those in a little bit. There is the stationary jaw, which is part of, just attached to that bar, that main scale, and then the movable jaw here that slides back and forth. You'll notice there's actually a little thing down here. We'll look at it, we'll see it better in some of the other views. Not that one. Okay, most of them have, this one doesn't. You have like a little thumb wheel down here that you can turn so you can move it with just your thumb. And you can move it very slowly for precision measurement. There are 4 ways a dial caliper can be used for measuring things. One is just the standard jaws. You know, when this is closed, this jaw here closes tight to there. This here actually slides past, so it's like right even with that. So the first way that this can be used to measure is with the main jaw, the large jaws, between here and here. So you can clamp those jaws down on something and get a measurement off of that. The second way it can be used to measure, so that would be an outside measurement using the main jaws. The second way it can be used to measure, there's an example of it, is an inside measurement using these smaller jaws on the top. And we said when those come together, this surface here lines up right there. This should be perfectly aligned. So as you open it up, it slides past it, and it would measure an inside surface, inside of a hole like that. Most people are aware of those two types of measurement on the caliper. The other two types are a little more subtle. This next one is a step. This piece here actually sets beside it, and actually if you looked at it from the top, you would have the bar here. This part of the jaw is just part of the bar. Then of course this straddles the bar and slides up and down. This piece here is right there, that little lip that is formed by that movable jaw. So I can use that to measure the height of a surface like this by setting that top edge of the jaw on the lower part and that lip on the top part. When this is closed, this, oops, I lost my pen there for a second. When it's closed, this edge here lines up perfectly with that edge. So as you move it up, the measurement on the bar is the distance between them. The final one, a lot of people see this little metal thing that slides in and out. In fact, I've seen people snip that off because it gets in the way. It actually is there for a purpose. It is a depth gauge for smaller holes. You know, this one is for measuring the difference between open surfaces. This is for actually going down into holes. You can insert it down into a hole like that and then use the edge of the caliper. So when the caliper is closed, again, this is exactly at the edge of that. So you can see there are a lot of things. Making these calipers is pretty tricky because there are a lot of things that have to line up when that jaw is closed and then move in a precision manner. Yes, the dial is still accurate because the dial is still, it still all goes off of this movable jaw moving up and down the bar. So you've got the bar or the blade is what this presentation is calling it, which is your main scale. And then the slider or the movable jaw, which has the dial and everything. Okay, so enough of that one. Let's get on to actually reading some measurements now. As we read these measurements, the first thing we have to figure out is, are we looking at an inch or millimeter, standard or metric? Well, looking at this one here is standard. And the way I can tell, there's two ways I can tell. First of all, this is 0.001. It's to 1,000th. If it were metric, it would only go to 100th. So that implies it is an inch. Oftentimes, it'll say 0.001 inches on that dial. So that gives it away that it's inches. The second way you can tell that this is standard or an inch micrometer instead of metric is here on the blade. We have two sets of numbers. You can see this 2 here is slightly larger, and then we have the smaller numbers. That 2 is the whole inches. That's saying there is 2 whole inches here. These are tenths. So all of these are tenths of an inch. Now, where you read these all depends on the style. This one is read at this edge here as it reveals the numbers as you move that sliding jaw down the bar, down the blade. The best way to tell is just close the jaws and see what lines up with 0. So if you close this jaw, it would be that edge that lines up with 0 on this caliper. So right now we are past the 2, that's 2 whole inches. We're past the 1, 2, 3, 4, and 5 tenths. That's saying 2.5 inches on the main scale there, off the blade. Then we go to the dial, and what's the dial saying here? 15, and that is 15 thousandths of an inch. Well, that just goes on the end of this. So there's 2.515 inches. Make sense? So this one, how many whole inches? 5. How many tenths? 6. And the dial? 21. And there it is, 5.621 inches. That's not so bad. So this one, whole inches. 3 tenths. 6 and dial? 66. So 3.666 inches. How about this one? Tell me what to do. It is 4 point. Why isn't it 9? We see the 9 there. How can we tell whether we're past the 9 or not? Look at the dial. If we were right on the 9, the dial would be at 0, right? Well, we haven't quite made it to 0 yet, which means we haven't quite made it to the next mark on the blade yet. So that is not to the 9, that is 4.8. And then off the dial, we get 87. 4.887 inches. How's about this one? Are we to the 3? No, it's just 0.271 inches. And this one? 4.443. Now this is slightly different style. Is this inch or metric? Is it standard or metric? Now you look here, it's still 0.001. If you look really closely, it says 0.001 inch, right? Means this one, however, if I close the jaw, it doesn't line up here. It's this little notch that lines up. So this is my reference edge. This is where I read the main scale on the blade. So how many whole inches here? 0.5, and then off the dial, 6.3. Very good. How's about here? Okay, how do we know it's past the 8? Yeah, the dial has just passed 0. That means we must have just passed the mark. So we had to be past the 8. So 0.814. And this one? Okay, perfect. It's 1.0 because we haven't made it to the 1 yet. Don't forget to put that 0 in there, though, because it is 0 tenths. And yes, it is 4.6. So 1.046 inches. And this one? 1.261. There we go. This one? Okay, 1.6. We have just passed the 6 because we've just passed 0. And yes, that is 09. How about this one? 1.8. We're not quite to the 9 yet because we're not quite past up to 0 yet. And it is 9.6. How about here? Perfect, 2.137 inches. This one? That's the same one. How about this one? 2.486. Okay, we're getting good at these. And this one? 2.836. Okay. Now we're going to look at one that's a little bit different. This is a 64th of an inch caliper. This is used, a lot of cabinet shops will use these. Mastercraft up here used to use a 64th, but a few years ago they switched over to decimal inches. They do go down to the 100th of an inch rather than the 64th of an inch anymore. The way this is read, this of course is 1 whole inch here. There we go. That is 1 whole inch. And then we read the rest of it off the dial here. And this is in 64. So our needle is right here. We have to figure out what that is in 64. So I usually go to the one that's labeled here like 1/8, and I have to convert that into 64. How many 64ths is that? Yeah, 8 times 8 makes 64, so 1 times 8 is 8 64ths. So that's 8, 9, 10, and 11 64ths. Which is it closer to, the 10 or the 11? 10? You guys okay with that? It's really, really close to being right in the middle, isn't it? So we'll call it 10 64ths. Of course, that can reduce to 5/32. So this would be called 1 5/32 inches. Not near as fun to read this one, is it? So here, how many whole inches? 0. And then my 64ths? Well, I've got 1/2 here, which is how many? 32 64ths. And 33, 34, 35. Between 34 and 35, which is it closer to? 34? Yeah. I would say slightly closer to the 34. Of course, that's going to reduce to 17/32. So that's reading 17/32 of an inch. How about here? It's hard to see from back there, isn't it? 1 whole inch. Oop, get back here. Here, let me see if I can maybe zero in a little bit more. There we go. So 1 whole inch, 5/16 here. 16 times what makes 64? 4, right? So 5 times 4 is 20. So that's 20, 21, 22. This one's pretty obviously right at 22, right? Or really close to 22. 22 64ths are reduced to 11/32. How about this one? How many whole inches? 1. It's right on the 7/8. We don't need to count out any 64ths there. And this one? 2 and we probably count backwards from 5/8 here. 5/8 would be 8 times 8, so 5 times 8 would be 40 64ths. So this would be 39. Very good. The good news is I will not test you on the 64th inch calipers, but I did want to show them to you just so you're aware that they are out there. And the scales I'm showing you are the most popular precision quality control scales. There are other calipers out there you can buy that have very different scales on them. Like you can go to Farm and Fleet and get some cheap calipers for stuff that are very, very different. If you order from like a Stefanali or I'm blacking out on the companies right now, but some of your most of your industrial quality control companies, they're going to be similar to this. What's that? Yeah, they would be the same scales. So now this one here. You look at this one is different. First thing we notice is, 0.01 millimeters. This is metric. Now the problem with metric, and it's always kind of annoyed me a little bit. This here is 1 centimeter. This is 2 centimeters. But this is in millimeters. So it's a little bit confusing. We cannot read this as 1 centimeter. We have to read it as 10 millimeters. And the same here, we have to read this as 20 millimeters. So when we look at this, Even though this is 1, 2, and 3, we have to read it as 10, 20, and 30. This is past the 3 because we've passed 0 here. So that is going to be read as 30 point, what's the dial tell us? 31. That is millimeters. So this one, this is 20. 1, 2, 3. Have we made it to the fourth one? No, not quite to 0. So that is 23.96 millimeters. So this one, what's it going to read on the blade here? 52. Very good. 0.41. This one? Yeah, 15, 16, 17.77 millimeters. And here, this is between, this would be 8 and this would be 9, but we have just passed 0, which means we did just pass the 9, and that is 12. How about this one? 62 here, 61, 62, and it is 0.48 millimeters. How about this one? 67.47. Very good. This one? 86.81. Not so bad? Okay. How about this one? Now, can we just put 0.5 or do we have to have the 0.50? We should put the 0.50, so we know that it was measured to the 100th of a millimeter. How about this one? 3.437. This is back to inches. This is the biggest mistake people make on calipers, is we go back and forth between inches and millimeters. The inches has 1 digit in front of that decimal point. The millimeters will often have 2 digits. Inches go to 1,000th, the millimeters go to 100th. So when we take a quiz, that is the biggest mistake people make, is they put that decimal in the wrong spot. So I'm warning you on that. Be very, very careful. Make sure you identify, is it inches, like this one, or is it millimeters? That's a great way to compare, by the way. You always look at the dial, that's 0.001. Well, this better have 3 decimal places in it, or we know we did something wrong. How about this one? 27.60. Perfect. And that is millimeters. This one. That one's kind of in your face, isn't it? 42. So yes, it's 1.1. We see that there are 2 different numbers up here, 2 different sets of numbers. So that's an indicator that's inches, and this is 0.001. So the 1,000th indicates inches as well. How about this one? 5.3. Perfect. And that is inches. This one? Is that 2.2 or 22? 22.37, and that is in millimeters. And this one? We actually have passed the 28.28. That's not inches, that is millimeters. Now, let me, oops. See if I remember which one I'm looking for here. Yep. I gotta flip this up. This, you'll notice, is missing what? Does not have a dial on it. This is a Vernier caliper. Now this is inch, because we do have two different measurements here. What you see up here, this is a Vernier scale. The way a Vernier scale works, and if I were to have a Vernier on the first quiz, at least, there won't be any Vernier scales on it. But you should be familiar with a Vernier scale because they do still come up in precision measurement. The way a Vernier scale works, it's really quite ingenious. As you see the spaces between these marks here on the main scale, the spaces on the Vernier scale, that is 1/1000th of an inch less than the space here. So like we read the main scale at the 0 of the Vernier scale. So this is where we read the main scale. This is 1.3 inches. Now I'll explain those marks between the 0.3 and the 0.4 later. Well, let me explain them right now. Those are called quarter marks. So this is 1.3. This would be 25, 50, 75, 1.4. So this is 1.350 is what that's saying, because we're past that second quarter mark. So 1.350. And obviously that's past that 50. Well, how far past? Well, we can go up here and see which one lines up. If we were 1/1000ths past it, this one would line up with the next mark. If we were 2/1000ths past it, this one would line up with the second mark, and so on. When we look to see what lines up here, and part of the problem is we have to look at this face on, head on, because it's in a picture like this. If I'm actually looking at a Vernier scale, I would take that caliper, instead of reading it like this, I would tilt it. So I'm looking down the lines, and then you can see exactly which ones line up. Even then, there's often 2 or 3 that appear to line up. Now here, we can see that it looks like the 14, well, the 15 doesn't. It looks like the 14 and the 16 line up. Technically, if 14 and 16 line up, the 15 should as well. But, well, life ain't perfect, right? This is saying that the 15 is the one that lines up, is what it's saying. Normally, if there are 3 that line up like that, 14, 15, 16, you take the middle one. If there's only 2 that you see that can look like they're lining up, you guess pretty much. If there's 4, you take one of the middle 2. So here, this is 2.325 because we're past a quarter mark. And we're reading it at the 0 here. So 2.325. Then we go up here and see what lines up. Well, it looks like the 13, 14, 15, 16 all line up. So I'd take either the 14 or the 15 and add it to that 2.325. If I had 14, it'd be 2.339. They're saying 2.340. So there is a little bit of guesswork as trying to decide which one of those lines up. We can run into a millimeter one. I believe this is the one I want. Yes, it is. So this is going to be just like the other one, 57.73. This is just the dial. I need to find my millimeter Vernier. That's not it. That's what was this measuring in? This is standard in inches, yes. Well then, has to be this one, huh? There it is. This is metric because there's only one set of numbers on the blade here. And this is still, 50, 51, 52, 53 millimeters. So this is past the 0 is past the 51. Now this doesn't go, it is really 0 to 100. This is 10, 20, 30, 40, 50, 60, 70, 80, 90. But notice there isn't 10 spaces in between, there's only 5. So each one of these is 2 hundredths. So this is 0.02, 0.04, 0.06, 0.08, 0.1. Does that make sense? So this is 51. And then what lines up here? I would say it looks like these 3 line up, these 4 line up. So it'd either be, I'd say either 36 or 38. So it'd be 51.38. They're saying 42. They're saying 42, but the 42 doesn't look anywhere close to lining up either. Notice, by the way, 51.42, how they're writing it with a comma in there instead of a decimal point. That's European style. In Europe, they use a comma instead of a decimal point. So that when they do their other numbers, they don't use commas every 3. They actually just use an extra half space between them. So it's something to be familiar with. You may end up working with companies that have affiliates overseas, and you will see numbers written like that. What's that? Maybe you'll have to go overseas to find a job. That's very possible. Okay, so for homework for tomorrow, I have a packet I'm going to hand out to you. So let me get that to you.